welcome to my channel. Today we'll be talking about a multi-speed fan motor which is shown here. This particular fan motor is used to control a blower fan that forces air into a room for a fan coil unit. These are the blower portion which, as it's rotating, is commanding air through this opening into the room. This is the front part of the fan coil unit, as you can see. So all this will be useless without the fan motor that is here. So if you have a situation where you find yourself confronted by this sort of challenge, my work here is to show you how you can identify the cables, which is the speed cables and the supply cables that are connected to the capacitors. These are the cables for the speed, and these are the two cables that are connected to a capacitor for supply. So I want to show you how to identify the various cables, which is high speed and which of them is for the neutral and all that. As you can see, this cable comes from the motor. This cable comes from the motor. And identify the various cables for the speed control and for supply of power via a capacitor. Now when you get something like this, all you need to do, you wire two of them. One of them is neutral, which is this, and then this is the earth. In this particular case, the brown is useless, but it's also part of the speed cable. You set your meter at resistance range, and point to the meter. Point closely. You can see it's on resistance range. So you get the first set of cable, which is for the speed control. Now you need to find out which of the cables is the common or the neutral. From that cable that is the neutral, you are very sure that as you test with one leg on that neutral cable and the other leg on any of the speed cables, you're going to get varying resistance. The high speed should have the lowest resistance, while the low speed should have the highest resistance. So in this particular case, let's assume this is clearly earth, and I believe that this blue is most likely the neutral cable or the common cable. I want to assume that these four, because in fan motors, most of the time black is always part of the speed control cable. So I want to assume that black, orange, and purple, and the brown are most likely the speed cables. But we need to start testing them since we are not aware of this. Remember, there is no schematic, so we are working with blindly. If I assume that the blue is the common connection, and then let me touch the purple. What are we getting? We'll record that 15.6. Then we try blue and black. One leg on the blue, the other leg on the black. Let's see what it's going to give us. $11.7. Take note of that. 15.6 was what we got for blue to purple. Now blue to purple. Now we're getting 11.6 on blue to black, which is a lower resistance. Then let's try which other color is there. Well, let's try blue and orange. So this is orange. Orange is here, which is the second terminal. This is orange. The other leg on blue. This is 18.7. This is obviously the highest resistance. So clearly the orange is the low speed, while the 15.6 is the medium speed, that is purple, and then orange is black is the highest speed. So with that, we have already separated these three guys. Now we are now left with these two, and we know that this is earth, while this is the common terminal. So with this, we are clear that we have been able to solve this problem of the speed cables. Then you have two separate cables. Obviously, these two separate cables are for power supply, and one of them goes to the run terminal while the other one goes to the start terminal. How do you confirm this? The common that you have here remains common for everything, which is our blue. So remember, common to run always have a lower resistance compared to common to start. So we are going to identify which of these is run and which of these is start. So we just get the probe on the common and see between these which is having a higher or lower resistance. Put it here. What are we getting? Meter. These two are supposed to connect to power supply. This is the white and this is the red. One of these is supposed to go to the start terminal of the blower, and the other one is supposed to go to the run terminal of the blower. Ideally, this is a situation where you don't have any schematics. You have to make these assumptions. So we want to find out these two cables, which one is going to the start terminal, which one is going to the run terminal. The only way we can determine that is to look at their resistances. In theory, the resistance of the run terminal should be lower than the run terminal to ground or to common should be lower than the resistance of the start terminal to common. And the sum of the two resistances should be equal or nearly equal to the resistance across the start and run terminal. So we need to record this quickly. Now, this is from common to this terminal. Let us assume that, call it 21 ohms from next cable now, and the same common. What are we getting? Let's take it at 0.4 ohm. 0.4 ohm. Now, obviously, the 21 ohm must be the 21.4 ohm. Clearly, should be the start terminal, while the 0.4 ohm or thereabout should be the run terminal, which run terminal. So let's confirm again. Between two of them, the sum of their resistances, the other two resistances, should be equal to the resistance that I'll get across these two. So let's confirm that. Let's confirm that. Let's confirm that. So we're having 21.7. If you add 21.4 and 0.4, that's about 21.8. So clearly, the sum of those two are nearly about the same with the sum of the resistance between the run and start terminal. So clearly, this motor is in good shape. Clearly, this motor is in good shape. Clearly, this blower is in good shape, and we can easily make our connections. So how do we connect that? So camera up close. So clearly what we'll do here now, we're going to connect, and also as it is now, we have two cables that are supposed to go to the start and run terminal. But the problem we have now is, how does the power supply come to one terminal, to the run terminal, which in this case is this? We need to confirm that our power supply is actually coming here. That connection has been made internally. So what it means is that internally, internally there is already a connection of one of these supply cables especially to the run. The run gets direct power supply line to it, and the capacitor, the other end of the capacitor, also gets supply to it. Internally, all this wiring has been done, but we need to confirm that by finding out whether there is a continuity between the run terminal and the supply cable, which tells us that our supply will be available at the run terminal, and also our supply will also be available at the other terminal of the capacitor. For instance now, our supply, ideally, our power supply is supposed to come here. The live is supposed to come here. When the live comes here, then the capacitor, which is going to the start terminal, in this case, this is the start terminal. The capacitor which is going to the start terminal will be connected here, one terminal of the capacitor, and the other terminal is supposed to also make contact with the supply. So I want to assume that this has been done inside, but to verify it, we need to know whether this point, which is the run, is having continuity to the supply cable. So let's verify that it should be continuous, so that by the time there is supply coming in from here, it should be able to give the necessary voltage at the run terminal, and at the same time enable the starting current that will go through the capacitor to start the blower. So what we're expecting here now is continuity between this run terminal and the supply or live supply cable. In this particular case, we can use any of the speed cables is a supply cable, because that's the part through which the voltage is available before it gets to the run terminal. So let's go and look at black, which is our high-speed terminal. What is it giving us? You can see there's continuity, and then we check the other one again, which is the medium speed. Our medium speed in this case is purple, as you can see. And then between the lowest speed, which is orange here, and the run terminal, there should also be continuity. So that clearly shows that internally all the wirings between power supply and the run terminal are in place for all the speeds. So power comes in through the black cable, which is at high speed, and goes to the run terminal. But this power, the current is reduced because of the resistance that has been placed there. But it's not as the full speed. There is still a little bit of resistance between the high speed and between the high speed and the run terminal. So at medium speed, which is our purple, we still have a little bit of more resistance than you have for the black. That's why at this, when there's a switch connection to the purple, the motor will run at a lesser speed than for black and purple. So having said that, we have confirmed that internally there's a connection between supply and the run terminal. We will now establish if there is a connection. By the time we put our capacitor between these two, we are now going to confirm that one end of the capacitor, because this is one end of the capacitor, which is, by the time there is supply on this, it provides that power supply required for one terminal of the capacitor, and the other terminal of the capacitor that goes to the start, which is here. So this is the result of the test that were done. If you look here now, you see that you can see that blue being the common during the speed cable test. You can see blue being the common, with black having the lowest resistance, purple the medium. This is how we came to our decision that orange must be the lowest speed, while purple will be the medium speed and black will be the highest speed. Same goes for our test on the run and start terminals. This is how we came to our conclusions. These are the values that we got, and with this analysis, this is the circuit. This is how the internal circuitry of the motor should be. Looking at this, you see that red being of a lower resistance to common compared to white is certainly the connection to the run terminal, while white having a higher resistance to the common certainly is connected to the start terminal. And based on that, we came about this circuit. These are the resistances This is a rotary switch, and this is the line. The line current comes here on one terminal, on a normally open terminal of the rotary switch, and once the switch is closed to any of the 3 terminals, the current travels this way into the motor. So that is why you see that black with current coming in from here into this direction. That's why black has the least resistance. And then increasingly, if this rotary switch goes on to purple, this resistance is now in series with this one, thereby reducing the speed. The current that is now available at the motor will be lower, thereby making it of a lower speed, or of a medium speed compared to the black. And same concept goes for orange. I think you can take a snapshot of this drawing and study it later. Thank you for watching my channel.